Okay, so welcome, Caroline. So we will start with the class. The class is today we'll start with the proof. We'll do the proof of reflection, a law of reflection, and then we'll say refraction. Okay. So first, okay. So now let's say there are two rays. First of all, this is the surface. This is a reflecting surface. Okay. So you have two rays coming, two parallel rays coming. So one ray will come like this, another ray will come like this. There are two parallel rays which are coming. So you remember, whenever there are two parallel rays comes, how is the wavefront? The wavefront is like this, yes or no? Planar wavefront,
Yes,
correct?
sir.
So
Yes, sir.
obviously the wavefront will be planar. This will be the wavefront, and you know that the wavefront and the direction will be 90 degree. So this will be 90 degree. This will be 90 degree. Correct or not? Yes.
Yes, sir.
Okay. Next, this wavefront is coming like this, and the first ray is hitting, and the next ray is hitting little after some time, because these are two parallel. So now we will consider that the wavefront is coming. The wavefront is coming and hitting. When the ray will come, the ray will get bounced. The ray will get what? Ray will get bounced like this. Similarly, this will also get bounced. Yes or no?
Yes, sir.
Yes. And this will get bounced. So we will get something like this. This wavefront will be like this. The same wavefront will get reflect and will come back here. That means if the wavefront is AB, okay, if the wavefront is AB, after it gets hit, this will be CD. That means this B is actually D and this A is actually C. Correct? Means this will hit and then this will again go back. So this B part is actually D part. This A part is actually C part. Clear?
Sir,
Clear?
can you repeat it, sir?
Okay, see, this is the wavefront, planar wavefront. The planar
Yes, sir.
wavefront will come and it will hit the surface and will reflect, like how the rays are going, how the incident, these are basically incident ray, correct? And these are reflected
Yes,
ray.
sir.
These are reflected ray. So similarly, this is the incident wavefront. This is the incident wavefront, and this is the reflected wavefront, correct?
Yes, sir.
So this AB, this A end is actually C end. Means after it gets reflected, this A is actually C end, and this B end is actually D end. Clear?
Yes, sir.
Clear, no? Okay. Now,
Yes, sir.
now, obviously, what is normal? Normal is the something which is perpendicular to the surface. Am I correct? So this
Yes, sir.
angle is how much? 90 degree. Am I correct?
90 degrees. Yes, sir.
And you know that incident ray with normal is the I. Am I correct? This angle is I. Yes or no? This,
Um,
yeah.
yes, sir.
No,
Yes,
no,
sir.
no, no, no,
Yeah,
not,
yes,
yeah.
sir.
This angle is I.
Yes, yes, sir.
1 minute. Okay. Okay. This angle is I. Now, what we saw, you saw this angle is also 90 degree. Which angle? This angle is 90 degree. The wavefront with this angle.
Yes,
Wavefront
sir.
with this angle. If this is 90 degree complete and this is I, this will be how much? 90 minus I or not?
Yes, sir.
This whole angle is 90 degree. This much angle is I. So the remaining angle should be 90 minus I. Not clear? Okay, wait. This is the incident wavefront, correct? So you know the angle between the ray and the wavefront is how much? 90 degree.
Yes, sir.
And now the angle between the normal and the incident ray is how much? In I? Angle I?
Yes, sir. Yes, sir.
This whole angle is 90 degree. This angle is I. Then remaining should be how much? 90 minus I or not?
Yes, sir. 90 minus.
Clear?
Understood, sir. Yes,
Okay.
sir.
That was the confusion. So I did a mistake somewhere. So I was not able to explain. So this is 90 minus I. Okay. Now, similarly, this angle between the normal and the reflected surface is how much? 90 degree.
Yes, sir.
Yes. This angle is 90 minus I. So what should be this angle then? I or not? The angle between the normal and the reflecting surface is again 90 degree, correct or not? This is the
Yes, sir.
wavefront. Yes. And this is the reflected light. Now the angle, if this whole angle is 90 degree and this one is 90 minus I, this part is 90 minus I, the remaining should be what? I or not?
Yes, sir.
Not clear? Again I will explain. Wait. This
Because I'm confused, like
why?
it should be refracted ray,
No.
right?
Wait no. First,
Okay.
first you understood why it is I. This
Yes, sir.
whole angle is 90 degree because angle between the normal and the surface is 90 degree, correct? Perpendicular.
Yes, sir.
So this angle is 90 minus I. We already told you, already we found out. The remaining angle should be what? I, because 90 minus I plus I is 90 degree. So this angle is I, correct?
Okay, sir. Understood. Yes, sir.
Here. Similarly, we will again draw a normal here. So now this is the R. So the reflected ray and the normal is R, correct? Yes or no?
Yes, sir.
So wait, this is a little small it became. This is the wavefront. If this is R, angle between the wavefront and the reflected ray is 90 degree. So what should be the small angle? 90 minus R, correct?
Yes, sir.
Because we know that the wavefront makes a 90 degree angle with the reflected ray. This is the reflected wavefront. So the reflected wavefront should make a 90 degree with the ray. This is 90 degree. This is R. So the remaining should be 90 minus R. Correct or not?
Yes, sir.
If this is 90 minus R and this is the normal again with the surface is again 90 degree. Correct? This whole
Yes, sir.
angle from here to here is 90. This is 90 minus R. So what should be this angle then? R.
R.
Clear?
Yes, sir.
Is it clear now?
Yes, sir.
Okay. So now see. Now we have, now this is your I, this is your R between this angle. So we have two triangles, ABC and ADC, correct? We have two triangles, though
Yes,
this is
sir.
not actually coming equal, but actually it should be equal. It should be like this. These are actually two congruent triangles. Clear? Clear?
Yes,
This is your I and this should be supposed to be here. Oh. Because the problem is I am not able to draw in this digital pen. Now it becomes a little difficult to draw. So this angle is how much? R. Clear? This is your B, this is your A, this is your C, and this is your D. So now let us take triangle ABC and triangle ADC. Clear? Clear? Yes. Now AC
yes,
is
sir.
the common side, correct? AC is the common side.
Yes, sir.
This is the wavefront and this is a reflected ray. This angle is 90 degree. Similarly, this angle is 90 degree. This is the wavefront making with the incident ray 90 degree. This angle 90, 90. This is the common side And what else? And what else? I didn't explain one more thing. So at t equal to 0, wavefront is here. The velocity of the incident wave is v. Clear? Velocity of the incident ray is v. Now at t equal to t, the wavefront goes here. The wavefront goes here at t equal to t. So now the velocity is v, t is equal to t, time is equal to t. So what should be the distance? This distance should be what? V into t or not? Speed, velocity into time or not?
Yes, sir.
So this distance is how much? Vt. Clear? Clear?
Yes, sir.
At t equal to t, this ray is coming here. At t equal to t, this ray is coming here. So this length and this length both are Vt. Clear? Clear?
Yes, sir.
T equal to 0, this incident rays are here and here. At t equal to t, this ray is here and this ray is here. So this length is also Vt, this length is also Vt. Clear?
Yes, sir.
So this Vt, this is also Vt, this also Vt. Now, first is angle B is equal to angle D is 90 degree. AC equal to AC common side, and AD is equal to BC. AD equal to BC is equal to VT. Clear? So now, but what condition it is congruent? By RHS, right hypotenuse side. Clear? Right hypotenuse side.
Yes.
This both triangles are congruent. So when the congruent, can we prove that I equal to R? If the both triangles are congruent, can I say angle I is equal to angle R? By what condition?
Yes, sir.
Congruent parts of congruent triangles. Clear? CPCT.
Yes, sir.
Clear? Any you
Yes,
you
sir.
want me to explain again?
No, sir, I'm clear.
Okay. So now what we saw that in Huygen's principle, in law of reflection, we were talking only about the rays. We are only talking about the ray, incident ray, reflected ray, normal. But here, what are we talking about? Incident wavefront, reflected wavefront, plane. This is the plane. Understood? Incident
Yes, sir.
wavefront, incident wavefront, reflected wavefront, and the plane. Previously, what we are talking surface, incident, and reflected ray. So this is the only change in what? Huygen's principle.
Principle.
Are you clear now? How to prove?
Yes, sir.
And this is the reflecting plane. This is the reflecting plane.
Thing.
So incident ray is substituted with incident wavefront. Reflected ray got substituted with reflected wavefront, and your surface got reflected with changed with reflected plane. This is a plane. Basically, this is a plane. Plane perpendicular. So everything is perpendicular. All everything is perpendicular. Clear?
Yes, sir.
Shall we go to refraction now?
Yes, sir.
Okay. So have you taken notes, or you want me to take notes? Okay.
I wrote it, sir.
Okay. Baba, I'm class rochi par kotha hochu. Okay. So now we'll go to refraction. So what is the basic difference between reflection and diffraction, Carlin? What is the basic difference between reflection and diffraction?
Uh, I don't know how to say it, sir.
Eh?
So I
Reflection
don't
happens only
know
in,
the exact definition
okay,
of it.
reflection happens in single medium, same medium. Refraction happen in the when the medium gets changed. This is the reflection. This is refraction. It is going inside, no? It goes away or goes towards the normal. Yes or no? Reflection is like
Yes, sir.
this. I equal to R. But what is refraction? ray going like this. If it is rarer to denser, okay, then it goes towards the normal. So this is your angle I and this is your angle R. But if it goes, if this is denser medium, this is rarer medium, then if it goes like this, it will go what? Away from normal. R, this is I. Understood?
Yes,
Clear?
sir.
If somebody
Yes,
asks you what
sir.
is reflection, refraction, you tell. Reflection happens, this is the same medium. This is the same medium. But here it is different medium. This is medium, one medium is what? One medium is
Rarer,
denser and
another
one is
is
rarer.
denser.
If both the mediums are same, then what will happen? The ray will directly what? Will go straight. Will go straight. Will go straight. Clear?
Yes,
Clear,
sir.
no? Only there's the only change that whenever the denser rarer, it is actually getting what? It will get diverted. Either
Negative.
if it is understood, no? Denser to rarer away from normal, rarer to denser towards
We
the
should
normal.
head away from it.
Clear? Don't tell
Yes, sir.
how to tell. This is a basic difference. And I is equal to R for reflection. Sin I by sin R is for
Refraction.
refraction. And this is called what law?
Snell's law.
Is a constant. Mu is a constant and it is a number. It's a number. No units are there for. Understood? It's only a number, ratio. Okay. So now we'll go to refraction. We have to prove refraction, laws of refraction using Huygen's law. Okay. Now same, what we will do? We will consider a surface. Basically, it's a refracting surface. Clear? It will allow. So again, we have same two wavefronts. Okay. Again, you have a incident. What? Incident. What is this called? Incident wavefront. Correct?
Wavefront.
But
Yes, sir.
now, what is the problem? Now, what is the problem? The
It's reflect.
velocity in this medium will be different than this medium. Yes or no? A
Yes, sir.
light,
Because
light,
it's such two mediums.
exactly. Light travels faster in air, but it will not go so fast in water because water is a denser medium. So light will slow down. The velocity of the light will slow down if it travels in a denser medium. If you compare between vacuum and air, so light speed is how much? 3 into 10 to the power 8. But what about air? The speed is 2.9 into 10 to the power 8. That means air is denser than vacuum. Correct or not?
Yes, sir.
So the velocity here, the velocity, this is the rarer medium, this is the denser medium. So the velocity of the rays will be V2 here, the velocity of the rays will be V1 here. So since the rays are going from the rarer medium to denser medium, remember V1 will be greater than V2. Correct? Clear?
Yes, sir.
Same, we will draw the what? We will draw the normal here. This will be your normal, this will be your I. Okay, obviously this is 90 degree. Again, angle between this is 90 degree, and you know this is also I. Why? Again, I will tell. The whole angle is 90 degree. This angle is I, so remaining is 90 minus I. Clear? Yes. Similarly,
Yes, sir.
the angle between the normal and this refracting surface is 90. The whole angle is 90 degree. So if this is 90 minus I, the remaining should be I. Clear? Okay.
Yes, sir.
Similarly, now this will get what? What will happen to this? This will now going to rarer to denser medium. So what will happen? It should bend towards the normal. Correct?
Yes, sir.
Similarly, this will also bend
Towards normal.
towards the normal,
Normal.
and both should be parallel. Correct?
Yes, sir.
Okay. Now what else? Now let us so this is the wavefront. What about the reflected wavefront? The reflected wavefront will be how? It will be like this. Understood? This will be like this. This wavefront, this will be your AB, This is your DC. So this wavefront has gone inside and this has gone. So see, the length will be same, by the way. It is actually not same, but it should be same. Don't get confused. So here the wavefront
Okay,
became
sir.
big. It cannot be big. It has to be two parallel lines. Okay. So this wavefront is actually the reflected wavefront, which after passing the surface is the refracted wavefront. Now this is your B, this is your D. So what will be your refracted angle? Angle between this will be R, correct? Why? The angle between the incident wavefront and the surface is I. Angle between the refracted wavefront and the surface is R, correct or not?
Yes, sir.
Okay, at t equal to 0, the both incident rays are here. At t equal to t, at t equal to t, this ray is here. This is at t equal to t. So that means this will be what? V2 into t. And what about this one? This will be V1 into t. Correct? Clear?
Yes, sir.
Means this ray after time t has passed the refracted surface and the velocity reduced to V2. But this incident ray, this ray has not even passed. It is still in the rarer surface. So the velocity remains same. So the distance travel is V1 into t and this is V2 into t. Clear?
Yes, sir.
Clear?
Yes, sir.
So
So
now
what about the refracted ray of V2, sir? Like the second ray.
refracted, which one? This one.
Like for first ray, the refract at T1 only. You'll get V 1 minute, sir. Which is V1 and which is V2?
No,
The
no,
first.
no. V1 is completely, both the rays are having speed V1, V1. Once it
Okay.
passes, once it crosses the surface, the velocity, this ray becomes V2, this also V2. But this ray at t equal to time t equal to t has passed the refracting surface. So the velocity
Yes, sir.
has reduced to V2. But here you see this ray is still in the, at t equal to it is still here only. It is still here only. So the velocity
Yes,
is
sir.
still V1. So the distance is V1t. Now you tell me, which is the greater distance? This distance is more or this distance is more?
Yes. This is more in V1T.
VD will be
Yeah.
more than AC.
Yes,
Why?
sir.
Because V1 is greater than V2. So obviously V1t should be greater than V2t.
Yes, sir.
Clear?
Yes, sir.
Okay. Now let us consider two triangles A, B, D. This triangle A, B, and D. Okay. So in ABD, if you consider, what will be sine I? This will be I, correct? What will be sine I? Sine of angle is what? Sine of I? P by H, no? Perpendicular by hypotenuse, correct? So
Yes, sir.
BD by what? BD by AD?
Eight,
P by
80.
H,
Yes, sir.
no? This is the hypotenuse. And in triangle ACD, what will be your sine R? This triangle will be V2T AC by again AD, correct?
Yes, sir.
Sin R will be perpendicular. Which is perpendicular? This angle, no? This is
Angle
this,
C.
this is the 90-degree, correct? So
Yes, sir.
AC by AD. Yes. So can we so what will be BD? BD is V1T by AD and this will be V2T by AD, correct? Yes,
So 1 minute, sir. Angle C at angle C only it's 90 degrees, right?
correct.
So for perpendicular, won't shouldn't we write CD?
How? Wait. This is the triangle, no? This is R,
Yes, sir.
this is 90-degree, this is
Yes, sir.
C, this is A,
Yes.
and this is D. So what will be sine R?
Hypotenuse. Okay, sir. Okay.
Perpendicular
I was
AC by
confused.
CD, AC by AD. Don't get confused. That's what I'm telling you. Don't get
Okay,
confused.
sir.
So AC by AD. So AC is V to T, AD is common side. Okay. Now,
Okay,
can
sir.
we divide sin I by sin R? Can we do both the equation? So can I rub
Yes, sir.
this? Can I rub this?
Yes,
Wait,
sir.
I will rub a part. Otherwise, you'll get confused. So sin I by sin R will be equal to V1T by AD divided by V2T by AD. Am I correct?
Yes, sir. And we can cancel AD and AD.
Exactly. It will become
We will want
V1T by
T by
AD
V2.
into AD by V2T. So this will be V1T by V2T. So TT cancelled, it will be V1 by V2.
1 by V2.
So what is velocity? Now what is Snell's law? What is Snell's law? Snell's law
Sin
is,
I,
yeah, tell me.
sin I by cos.
Sin I by sin R, sin I by sin R equal to mu. What is mu? Mu is refractive index. And what?
1 minute, sir. Isn't it cos I? No,
Cos I, yeah. Why?
uh, no, I noted right, let's sir.
No.
Sin I by,
It is sin I only. Check it properly. Check in book. Sin I by
okay, sir.
sin R. Okay. So what is sin I by sin R? Sin I by sin R is a constant, and that constant is called mu, refractive index. And this refractive index, the definition of refractive index is the velocity of light in the first medium by second medium. So the velocity of refractive index in first medium by second medium. Clear? Clear? So sin I by sin R equal to V1 by V2 is equal to constant, and this constant is mu. Hence proved. Clear? Clear?
Yes, sir.
Okay. Now I forgot. This is 90 degree. Okay. This is 90 degree. This is angle R. So what will be this angle? It will be 90 minus R. Am I correct?
Yes, sir.
This whole angle is 90 degree. Yes or no?
Yes, sir.
This angle is 90 minus R. What about this angle? It will be R or not?
R, R. Yes, sir.
Clear?
Yes, sir.
That's it. Little confusing, no?
I'm clear, sir. Maybe if I learn again, it will be more clear.
Yeah, you just practice it. Anyway, you have the video. You can just go through the video. Okay, so don't worry.
Yes,
And maybe probably, the problem is you have to draw it nicely, then only you will understand. So remember,
yes, sir.
the angle between the wavefront and the ray is always 90 degree. Angle between the normal and the surface, reflecting or refracting surface, is again 90 degree. That's it. There is the magic. Clear?
Understood, sir. Yes, sir.
Shall we go ahead?
Yes, sir.
So we will talk about interference. We'll just give today we'll give the, what we'll give. We'll try to give the intro only. Okay. Interference, I don't want to start completely because people are still missing. So I will only give the intro. What is
Okay,
interference?
sir.
What is interference? Basically, remember, when you say two rays, I have two rays. One ray is like this, and another ray is like this. If these two rays are superimposing, if I superimpose, what do you mean by superimpose?
Merging.
Merging. So if the both rays are together, so if the amplitude is something like A and this also like A, if I merge it, so will it not become bigger?
2A. Yes, sir.
Yeah, it will become 2A. This is in phase. In phase means what? the starting of the wave and the ending of the wave are both in phase. You understood? That means
Yes,
they
sir.
are completely in phase. They are in phase. There is no phase difference. There's no lagging. But it might happen that you might have two waves like this. You can have like this. In this type of wave, if this is A and this is minus A, so what you will get? You will get only a 0.
Zero.
Why?
No way will we get
Because A,
because the
yeah,
destructive
it is called destructive superposition.
interference.
Clear? Clear?
Yes, sir.
Very, very important. This is called superposition. What is called?
Total precision.
Superposition of waves. This is called, first was constructive, second is destructive. But we might happen, it is completely out of phase. It might not be like this. It might be like this. Here, you might get a wave like this. So this is not completely in phase, neither it is completely out of phase. It is partially out of phase. Correct or not?
Yes, sir.
So these are different kind of what? Interferences, different type of superposition. So what we will study mostly about this one. It's the third type. First type is a basically exception. Both are exception. What we studied previously, 1, 2 are exception. This will be the normally the what we are going to study. Clear?
Yes,
Clear?
sir.
So
Yes, sir.
the first one, your y amplitude, resultant amplitude. For the first one was y1 plus y2, correct? Second one was destructive. It was y1 minus y2, correct?
Yes, sir.
And the next one was what? So remember y1 and y2 and y1 and both y1 and y2 plus and this minus. And here, because it is same, so now this will have two categories. One is will get 0, where if both the amplitude are same, it gets 0. And one, if both are not same, you will get some value. Correct or not?
Yes, sir.
1 minute. या नूर बताना, नहीं पढ़ा रहा था, बताना पढ़ा रहा था. अरे मैं तो बंद कर दिया. चल ठीक है, ओके चलो. So what I'm saying, first one was clear, right? Second one will have two categories. One will be 0, where if both are amplitude are same, if y1 is equal to y2, then it will be 0. If it is not same, then you will get some value. Correct or not?
Yes, sir.
Okay, this is called resultant amplitude. This is what you call resultant amplitude. Clear?
Yes, sir.
Okay, so write down what is superposition principle. Very, very important. When two or more waves, write down, when two or more waves are traveling in the same medium, when two or more waves are traveling in the same medium, then the resultant displacement of a particle the resultant amplitude of a particle
Sir, resultant displacement or amplitude?
resultant displacement of a particle, sorry,
Oh, okay,
resultant
sir.
displacement of a particle when two or more waves are traveling in the same medium, then the resultant displacement of a particle is the
Of
vector
the particle.
sum of displacement produced by each wave.
When two or more waves are traveling in same medium, then the resultant displacement of a particle is the vector sum of the resultant produced by each wave.
Is the vector sum of displacement produced by each wave.
Oh, okay, sir.
Vector sum of displacement produced by each wave.
Okay, sir.
Clear?
Yes, sir.
Okay. So we have two waves. One wave is y1 equal to a1 sine omega t plus kx. I told you, no, this is basically a what? Sine wave, yes or no? So this will be a sine function. Second, we have another wave where a2 sine omega t plus kx. Clear? That means both the amplitudes are same, different. Yes or no? A1, A2.
Yes, sir.
Clear? Frequencies are same. They are same frequency. One is like this. One is smaller, but same frequency. That means in 1 second, how many of a crust is there? Same crust is for this. Only thing that the varying amplitude. Clear? F1
Yes.
omega lambda. That means the wavelength, the angular frequency, the normal frequency are all same. Velocity of the wave is also same. Amplitudes are different. And what is k? K is nothing but 2 pi by what? Lambda. And what is omega? 2 pi f. Yes or no? Yes.
Yes, sir.
So what will happen? So what we will do? We will get y net. So y net will be what? Y1 plus y2. That is equal to a1 sine omega t plus kx plus a2 sine omega t plus kx. Am I correct?
Yes, sir.
Yes.
Yes, sir.
So what will be this? This is basically a combination of what? We already studied this, no, in AC. Simple harmonic motion. Yes or no? Simple harmonic motion. Now, you remember in when we talk about the vector phasor diagram, this part was what? Phi. Yes or no? What is this part? Phi. Are omega t plus phi, no? Where used to get an angle. Phi used to find
Yes, sir.
out tan inverse of, you remember, xl by
Yes, sir.
xc, xl by all that we used to find. Oh, this I
Yes,
made a
sir.
mistake. It is x1, this is x2. Okay, so this will be kx1, this will be kx2. Clear?
Yes,
Clear?
sir.
Omega t plus kx1, omega t plus k2. So what is phi? Your phi is nothing but phase difference is what? Phase difference of first wave minus phase difference of second wave. That means kx1 minus kx2, which is k of x1 minus x2. Clear?
Yes, sir.
Or it will be k into delta x equal to delta phi. Clear? Clear?
Yes, sir. Yes, sir.
So can we write instead of k is equal to 2 pi by lambda, instead of that, so it will be, can we write k into lambda x will be 2 pi by lambda into delta x? Yes.
Yes, sir.
So this will be what? K delta x will be delta phi. So delta phi will be 2 pi by lambda into delta x. Yes or no?
Yes, sir.
Yes. Okay. Now, clear? Now, let us go. So basically, what are this? I told you, this is a what? Vector. This also a vector. Yes or no?
Yes, sir.
So we have to find out the vector sum. We have to find the resultant. So what we will do? This will be your A2 and this will be your A1 and this is your AR resultant. Correct? So
Yes,
resultant
sir.
is making angle theta with respect to base. So this is the direction. And what about the phase difference? This phase difference is what? What?
2, 2 pi delta by lambda delta x.
Exactly. 2 pi lambda into delta x. So basically it is phi. You don't write delta phi, you don't write phi. This angle is phi. Clear? Yes?
Yes, sir.
So what will be our resultant formula? You remember? Same formula. Any vector addition. A1 square, A2 square plus 2 into A1 into A2 into cos phi. Clear? So AR will be, so no. This is your A, not AR square, this is AR. So AR square will be obviously A1, you remove a root over, correct?
Yes, sir. It will be
So
A1.
exactly. So what will be your tan theta? What will be direction? Tan theta will be formula. You remember B sine phi, B sine theta by A plus B sine theta. Yes or no? So what is your B? This is your B, this is your A. So B sine theta. So A1, A1, no, not B sine theta or A sine theta. A sine theta. So A2, this is your A. A2 sine phi divided by A1 plus A2 cos phi. This is the formula. You remember the formula? Direction.
Yes, sir.
Clear? You got the theta.
Yes, sir. And yes, sir.
So what will be your y net? What will be your y net?
Um, A1 sine omega t plus
First AR,
phase
no? First
1
AR is there, no resultant. Amplitude will be resultant amplitude. AR. Sine omega t
plus k
plus kx1 plus theta.
plus
Okay?
yes, sir. Understood.
Clear?
Yes, sir.
So we will study more in the next class. I don't want to go ahead. Today it will be too much bombarding. We'll go ahead in the next class. Clear? So just learn Huygens law. Very, very important from exam point of view. You might get a question. Explain Huygens principle. Very, very easy. Okay? But study this.
Okay, sir.
Okay? I will give you the recording after some time. Okay?
Okay, sir.
Okay, beta. Bye.
Thank you, sir.
Carolyn, what about my Christmas gift? You're not giving anything?
How can I give, sir? I'm in Chennai now,
Yeah,
and
yeah,
you're in Mumbai.
yeah. I was
If at
one
all I
since.
meet, I'll surely give.
Don't worry, beta. First you get job. First you get something very good. Then you give teacher. Okay. I'll be
Okay,
very
sir.
happy if you rise. Remember, a teacher will be happy only when a student rises. So my Christmas gift is that you should get 95% and above in 12th. That will be my Christmas gift. Remember.
Sure, sir.
And if you should crack, you should become a doctor. When you become a doctor, when your sir becomes old, you will treat him free of cost because sir will not have any job that time. Yes or no? Chalo, take
Okay,
care.
sir.
Bye.
Thank you, sir. Bye.